This video we're going to look at binomial distribution. This is part of our GCSE Further Mathematics statistics section of the applied module. Okay, first of all, we're going to look at how we expand certain things. So if you have a plus x to the power of 1, that is just going to be a plus x. Now if you did a plus x squared, now if you did that out, you would have to do a plus x upon a plus x. Multiply it out, what you're going to get is, I'll get rid of all of that, what you're going to get is just a squared plus 2ax plus x squared. Okay, and if you did the same, so you did your a plus x cubed, what you would get after a lot of working out, so you would have to take this thing and multiply by everything by a plus x, and what you would get is a cubed plus 3a squared x plus 3ax squared plus x cubed. Now if you imagine you went on to the next one, you did ax to the power 4, what you would get would be a to the power 4 plus 4 times a cubed x plus 6 times a squared x squared plus 4 a times x cubed plus x to the power of 4. Now this is very hard to do, so imagine if you wanted, you were to just jump in at the very start and do, somebody said find a plus x to the power 4, you would have to do that all out, a plus x upon a plus x upon a plus x upon a plus x. Now I know for a fact I would make a mistake when I was doing that. That's very difficult to do without making a mistake. So we're going to give you a much nicer way of doing a question of this form, and that's by using a thing called Pascal's Triangle. So on our next line, I will zoom out a little bit so we can see the relationship here. On our next line we've got Pascal's Triangle, and I'm just going to talk about the relationship first, and then I'm going to tell you how you can actually draw Pascal's Triangle for yourself. Now the first thing is 1. If I should have added in an x to the power of 0. Anything to the power of 0 is just 1. Now what we've got here, we've got a 1, a, and 1x. So far we've got 1, and then the next line is 1 and 1. So we've got up here 1, 1 and 1. Next line, if you read off your a plus x squared line, you've got the coefficients. So the number in front of the terms is 1, 2, and 1. And what have we got in the third line? 1, 2, and 1. In your next line, so this is your a plus x cubed line, you've got 1, 3, 3, and 1. And what have you got here? 1, 3, 3, and 1. In your next line, you've got 1, 4, 6, 4, and 1. And of course, you've got here 1, 4, 6, 4, and 1. And your next line, so you now know, if you were to do your next line, so if it was a plus x to the power 4, you might not have realized just yet what way the letters are going to work, your a's and your x's, but you will realize that the number terms are going to be 1, 5, 10, 10, 5, and 1. And this is Pascal's triangle. So I'm going to look now at just how we actually get that, and then we'll do a couple of examples on this as well. Okay, it says here, for Pascal's triangle, each term is found by adding the two terms directly above. So to do your Pascal's triangle out, first thing you do is you put a 1. And the next thing is you put a 1 and a 1. And then from there on, each term can be found by adding the terms above. So between your 1 and your 1 below, you add the 1 and 1 and you get a 2. And then there's going to be 1 either side. Between your 2 and your 1, there's going to be a 3. Between your 2 and your 1, there's going to be a 3. And you put a 1 either side. Between your 3 and your 3, you're going to have a 6. Between your 1 and your 3, you're going to have a 4. Same over here. Between your 3 and your 1, you're going to have a 4. You've got 1 either end. And between your 4 and your 6, you're going to have a 10. Between your 6 and your 4, you're going to have a 10. Between your 4 and your 1, you're going to have a 5. You're going to have 1 in the end. Between your 1 and your 4, you're going to have a 5. And you're going to have a 1 in the end. And you could keep going. This goes on forever and ever. But you're very rarely going to have to do it further than find p plus q to the power 5 or a plus b to the power 5. We're going to look now at how we can use this and to expand terms. So the last one we looked at was our p plus q to the power 5. So it was p plus q to the power 5, the coefficients were 1, 5, 10, 10, 5, and 1. Okay, the Pascal's triangle gets you a coefficient, and that is it. So we have to understand what is going on next. So, very importantly, if it's p plus q to the power 5 is the biggest power that anything could have been. So power 5 is the biggest power that p could be when you do this expansion. Power 5 is also the biggest power that q can be. And also, more or equally important anyway, when your first term then is p to the power 5. Your next term is then 5 times p to the power 4. So our power of p goes down by 1. And as it goes down by 1, the power of the other thing goes up by 1. So it's 5 p to the power 4. There were no q's here. So that was q to the power, this really was q to the power of 0. You wouldn't write that in. So this now is q to the power of 1. Next term, your coefficient of the next term is a 10. And your p term goes down, the power of it goes down by 1, so it's now p cubed. And your q term goes up by 1, so it's p squared. So 10p cubed q squared. Your next term, the coefficient of it is 10. And your p term, the power of it goes down by 1, so it's now p squared. Your q term goes up by 1, it's q cubed. And your next term, it's a 5. And then that's going to be p, because the p term goes down by 1. And your q term goes up by 1, so it goes up to q to the power 5. Q to the power 4, sorry. Your last term, the coefficient is 1. Your p, so there we are, that's really you could have a 1 in here. So it's 1 times p to the power of 0, which just is 1. And your q term goes up by 1, so it's q to the power of 5. And that's it. Okay, so a couple of things which are very important. You've got your coefficients, but we're not really looking at coefficients this time. We're looking at the powers. So your sum of the powers always adds up to this number, whatever this number happens to be. So the sum of the powers always adds up to this. So 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and 5 plus 0 is 5. So your combined term, PQ, what P to the power of whatever, Q to the power of whatever, those two powers always add up to this thing here. Okay, we're going to look at how we use this then to expand our these expansions here. We've got p plus q to the power of 6, p plus q to the power of 7, and 1 plus x to the power of 8. And I said we very rarely go beyond power of 5, but here we are going well beyond it. So we'll see how we have to do this. So for these questions, the first thing we want to do is draw a decent Pascal's triangle out. So I'm going to start doing my Pascal's triangle now. So for your Pascal's triangle, you've got your 1 is your first term, you put down, then below it 1 and a 1, and then you fill in 1 plus 1 is 2, you put the 1s on each end, 3 and 3, 1s on each end, and adding the two terms above to get you 6, 4 here, and a 4 here, and a 1 on each end. That's going to be 10, 10, 5, 5, and 1. And then we need to go on to 8 is our biggest one, so we need to go on to 8, so 3 more lines to go. It's going to be 20, 15, 6, and 1. It's going to be 20, 15. And that's going to be 6 and 1. That's going to be 35, 21, 7, and 1. This way it's going to be 35, 21, 7, and 1. And our last line for us is going to be 70. It's going to be 56. It's going to be 28. It's going to be 8. And it's going to be 1. It's going to be 56. It's going to be 28. It's going to be 8. And it's going to be 1. Now just imagine, folks, how difficult that would have been to multiply it out. For example, 1 plus x to the power of 8 to try and get all of these coefficients and not make a mistake. It would be very, very difficult to do that. Okay, part 1, we have got p plus q to the power of 6 is what we have to do. So we're looking at this line. And very importantly, if you're power of 6 then, you know to look at the line that starts with a 6 in here. So that's what we're looking for in this one. So it's p plus q to the power of 6. Your first coefficient is 1. and your first letter is going to be p to the power of 6. Next coefficient is 6, so that's going to be p to the power of 5. Q. Next one is 15, so that's going to be 15 p to the power of 4 q squared. Next one is 20, so that's 20 p cubed q cubed, plus it's going to be 15 p squared q to the 4, plus it's going to be 6 p times q to the power of 5, plus it's going to be q to the power of 6. Next one we'll have to do is p plus q to the power of 7. So p plus q to the power of 7, same idea. So this time we are looking at the next line down. So we're looking at this line here. So the first coefficient is 1, so that's going to be p to the power of 7 plus 7 p to the power of 6 q to the power of 1 plus 21 p to the power of 5 q squared plus 35 p to the power of 4 q cubed plus 35 p cubed q to the power of 4 plus, and it's going to be 21 p squared q to the power of 5 plus 7 p times q to the power of 6 plus q to the power of 7. So just to remind us, remember your powers, the sum of the powers always adds up to, in this case, adds up to the 7. And as you decrease your power of p, you increase your power of q. Okay, last part asked us to find. It was 1 plus x to the power of 8. So we're looking at this line here. Now this maybe confuses people a wee bit, but just treat your 1 is instead of your p and your x is instead of your q. So it's going to be 1. And we'll just put it in the brackets. We won't really need to, but we'll put it in a bracket just so that if we get a number different than 1, we know how to do it. So it's going to be 1 to the power of 8 plus 8 times 1 to the power of 7, and that's going to be times your x. We definitely don't need to put that in a bracket. X to the power of 1, and then plus it's going to be 28 times 1 to the power of 6 times x squared plus 56 times 1 to the power of 5 times x cubed plus 70 times 1 to the power of 4 times your x to the power of 4 plus we're now on to 56 times 1 to the power of 3 times x to the power of 5 plus 28 times 1 squared times x to the power of 6 plus 8 times 1 to the power of 1 times x to the power of 7 plus, and then it's just 1 times 1 to the power of 0, which is just 1. And then you've got your x to the power of 8 term. Now in this one we need to tidy up. Not a lot of tidying up to do in this one because it's just 1 to the power of anything is just going to be 1. So really you just have 1 plus 8x plus 28x squared plus 56x cubed plus 70x to the 4 plus 56x to the 5 plus 28x to the 6 plus 8x to the 7 plus x to the 8, and that is it done. This example says find the fourth term in expansion a plus x all to the power of 5, and then use this to find the fourth term in expansion 2 over 5 plus 3 over 8 all to the power of 5. Now the first thing I'm going to do here is draw my Pascal's triangle so I can find what the coefficients will be for my a plus x to the power of 5. So Pascal's triangle, 1 at the top, then 1 and 1 below, and then get your 2 by adding the 1 and the 1, put 1s on the outside, and continue that pattern on down until you get down to the row containing 1 and then 5. So this is the row we're looking to do. So now we can say a plus x to the power of 5 would be equal to a to the power of 5, and it's 1a to the power of 5 plus 5 times a, and the power of a reduces by 1, so it goes down to 4. Power of x increases by 1, so it goes up to x to the power of 1. Next term is 10, and a goes down to a to the power of 3, x goes up to x squared, plus 10, a goes down to a squared, and x cubed, plus 5a times x to the 4, plus x to the power of 5. Okay, that's what we've got for your a plus x all to the power 5, and it asks you to find the fourth term in the expansion. So the fourth term, there's your first, your second, your third, your fourth. So this is our fourth term. So we just say fourth term is equal to 10a squared x cubed. Just say, so the fourth term of, and what was our thing? It was 2 over 5 plus 3 over 8, and that's the power 5. Just say will be equal to 10. Instead of a, you've got 2 over 5, and it's getting squared. Instead of x, you've got 3 over 8, and it's getting done to the power of 3, and raised to the power of 3. And then if you do that on your calculator, you will get 27 over 320. We're going to look now at how we can use binomial to work out probabilities. So in a situation where there is only two possible outcomes, so quite often deemed a success or fail, so maybe you're tossing a coin and a success is getting a head, a fail is getting a tail, or maybe you're rolling a dice and success is getting a 5 and fail would be not rolling a 5. So there's your two possible outcomes. If a situation can be modelled that way, then it is quite often follows a binomial distribution. So, and that's because the sum of the probability, so if P is a probability of success, Q is a probability of failure, then the sum of those probabilities equals 1. So for example I used there was tossing a coin, success was a head, a half, fail was a tail, which is a half, half plus a half gives you 1. Or rolling a dice and success was a 5, getting a 5 is 1 over 6, not getting a 5 is 5 out of 6, 1 over 6 plus 5 over 6 gives you 1. So when n trials are performed, the probability of success is constant, and each result does not depend on the success of previous trial. The probabilities follow, and then the probabilities follow the binomial distribution. So for n trials, the probability of r, that means r is the number of successes. This will be the rth term in the expansion of p plus q to the power of n. So let's have a wee look at how we do this in an example. This example says the probability that somebody will score a penalty is 0.7. If 6 penalties are taken, what is the probability of scoring 2 goals, 3 goals, 4 goals, or at least 1 goal? So what you must do first of all is write out what are your, how many times, what is your n, what is your p, and what is your q. So n is your number of trials. So the probability that somebody will score a penalty is 0.7. If 6 penalties are taken, so 6 is your number of trials, and the probability of success is 0.7. That means the probability of failure is 1 minus 0.7, so 0.3. And you're set up, good to go. So we want to find the probability of success. So probability of getting 2 goals. So we're looking for, and we'll do out our probability distribution first of all. So from your Pascal's Triangle, which I haven't drawn this time, but if you did it out, P plus Q to the power of 6 would be equal to P to the power of 6 plus 6, P to the power of 5, Q to the power of 1, plus, it's going to be 15, P to the power of 4, Q squared, plus 20, so yep, 20 P cubed, Q cubed, plus 15 p squared q to the power of 4 plus 6 p times q to the power of 5 plus q to the power of 6. And what we want in this question, we want 2 goals. So we want 2 goals scored. So it is a term containing p to the power of 2. So the term containing p to the power of 2 is 15 p squared q to the power of 4, which is equal to then 15 times, and that's going to be, our p was 0.7 squared, our q was 0.3 to the power of 4, and you do that on your calculator, you will get 0.059535, which works out as be 0.0595 to 3 sig figs. So 3 sig figs, because that's typically what they ask you for in a GCSE Further Maths exam. Next question asks you to find 3 goals, the probability of scoring 3 goals. So this is the probability of scoring 3 is the way I'm going to write this one. And it's going to be the term that contains your p cubed. So it's going to be 20p cubed times q cubed. And if you do that out again, that's 20 times 0.7 cubed times 0.3 cubed. And you do that on your calculator, you'll get 0.18522, which again, the 3 sig figs is 0.185 to 3 sig figs. The next question asks you to find the probability of 4 goals. So part 3 is you're looking for the probability of 4 goals. So again, it's the one containing p to the power 4, which is going to be 15 p to the power 4 q squared, which is going to be 15 times 0.7 to the power 4 times 0.3 squared. And if you do that out, what you will get is 0.3232435, and that is going to be 0.324 to 3 sig figs. Okay, part 4, it asks you for at least 1 goal. So at least 1 goal, so probability at least 1 means you could have 1 goal, you could have 2 goals, you could have 3 goals, you could have 4 goals, you could have 5 goals, or you could have 6 goals. So it's everything except no goals. So it's 1 minus the probability of none. Okay, that's the easiest way of doing it. So it's 1 minus, so no goals is going to be q to the power of 6. So that's going to be 1 minus q to the power of 6 is going to be 0.3 to the power of 6. And if you do that on your calculator, you get 0.999, and that was the 3 sig figs. So it's incredibly likely, basically, that somebody's going to score at least 1 goal. And if you think about it, you're getting 6 penalties, and the chance of you scoring on a single penalty is 0.7. So if you do 6, there's almost a certainty then you're going to score at least one of your 6 penalties. This is our last example. It says, in a street, 3 out of 5 houses have a garage. What is the probability that in a group of 8 houses, 5 houses have a garage for part 1? First thing we're going to do is set up our situation. We have got our group of 8 houses, so n is equal to 8. Your probability of success is equal to, it is 3 out of 5. I'm just going to write that as a decimal, as 0.6. That means your probability of failure of not picking a house that has a garage is 0.4. Once you've got that done, we can get started. So what I'm going to do first of all is do my Pascal's Triangle. So I'm going to pause the video and just do out my Pascal's Triangle, the rest of it, and then we'll pick up where we left off. There you go, as if by magic, there's your Pascal's Triangle. Just beneath the Pascal's Triangle, we'll just write out what our p plus q to the power of 8 then is. P plus q to the power of 8 is going to be equal to p to the power of 8 plus 8 p to the power of 7 times q plus 28 p to the power of 6 times q squared plus 56 p to the power of 5 times q cubed plus 70 p to the power of 4 q to the power of 4 plus 56 p to the power of 3 q to the power of 5 plus 28 p squared q to the power of 6 plus 8 p times q to the power of 7 plus q to the power of 8. Okay, once you get your expansion, you're good to go and answer whatever they want you to give. So the first part of the question said to find the probability that you had 5 garages were selected. So 5 garages is going to be the one that contains p to the power of 5, so it's going to be this one I've just underlined. So it can be 56 times p to the power of 5 q cubed, and then just fire in your values. That's going to be, our p is 0.6 to the power of 5, q is 0.4 to the power of 3, do that on your calculator, you will get 0.27869,184. So the 3 sig figs is going to be 0.279 to 3 sig figs. Okay, part 2. Part 2 asks us to find the probability of 8 garages. So 8 garages is going to be the first one, so p to the power of 8. So it's just going to be p to the power of 8, which is very easy for us. It's going to be 0.6 all to the power of 8, and you do that on your calculator. Maybe 0.0168 to 3 sig figs. Part 3. Part 3 asks us to find at most 7. So probability at most 7. See, and that means 1 minus the probability of more than 7, because at most 7 means 1, 2, 3, 4, 5, 6, and 7. So it's everything except more than 7. So that's 1 minus, and more than 7 in this case just means your probability of 8. So that's going to be 1 minus, and we had that already from earlier on. So 8 was 0.6. I'm going to write it out as 0.6 to the power of 8. Do that on my calculator again, and if I did that on my calculator, what I would get is 0.983 to 3 sig figs. So just notice, had I used this as my answer, I wouldn't have got the same thing, so I show a wee bit more working out for that one. And then part 4, it asks you for at least 1. So probability at least 1 means 1 minus. So at least 1 means I could have 1, I could have 2, I could have 3, I could have 4, I could have 5, I could have 6, I could have 7, I could have 8. I could have everything except none. So it's 1 minus the probability of none. This is a very common question for them to ask. They're very fond of this one. So that's none would be q to the power of 8, which is 1 minus 0.4. Just put down the bracket to the power of 8. And if you do that on your calculator, you will get 0.999 to 3 sig figs. So let's think about that as an answer. Think why that makes sense. So remember, this was picking a house that has a garage. The probability of having a garage was 0.6. So if you pick 8 houses, there's a very good chance at least one of them is going to have a garage. And that is us done for our binomial video.